Let's learn how to read a titration curve between NaOH, a strong base, and HCl, a strong acid. So before I start the titration, we can say that 0 milliliters of NaOH is added to the flask, which means that all I have sitting in this receiving flask is HCl. So the pH here is 1 to represent its concentration of 0.1 moles per liter. As you start to titrate base into the flask, we're going to indicate that on here, like we're adding milliliters of base, but notice the pH is still in the acidic range. So if that occurs, what we have to look at is the stoichiometry. I know that in this segment, HCl, which is my acid, is the excess reactant. So there's more moles of acid, even though you just started the titration. Okay, but at some point, you're going to add enough base, and we call that this point the equivalence point. So equivalence point means that my moles of acid equals the moles of base. So in other words, neither of them are excess, and what you have at the equivalence point is water and sodium chloride, so water and salt. Now, if you keep titrating though, if you keep adding drops of base into the flask, you're going to notice that the pH shoots up all the way up to 14 or close to 14. So in this segment of your graph, we can say that if we look at the stoichiometry, because you've added extra base, NaOH is excess, and that's how we read our titration curve. There's a lot more detail to acid-base titration. If you would like to see a long-form video of this concept, please let me know. Thank you so much.